Hello everyone and welcome back to the part 2 of this tutorial. Last week we created a door that was fully parametric in its dimensions, and now today we're going to assign a few more parameters to it. So let's get started. So now would maybe be a good time to evaluate what we have so far. So geometry wise we have the frame and we have the door. And then as parameters we have the height and the width that were both given to us, and we have the frame thickness that we wanted to have. So next would maybe be to create the parameter for the frame material and the door material. To generate a material parameter, you just simply need to click on the object, and then here in the properties you can see the material which is not assigned to any parameter. So we click on this little gray rectangle, and then here we can create a new parameter which is pre-selected to be a material parameter. So we call this door material. Okay, and then do the same for the frame. Frame material. Okay. So now we have those parameters in our family types as well, and when you use the door in your project you can set those materials to anything you want. So now comes the tricky part where we actually make this door openable. So for this we go back to the reference level, and then we select the door and make a copy of it, and then we rotate that copy by 90 degrees. And now we need to put this door where it would be if it was 90 degrees open. So for this we open up the extrusion by double clicking it, and then press the tab key to select all lines, or draw a rectangle to select all of them. And now we can press MV, which is the shortcut for move, to put it somewhere around here, because it would rotate around an axis that would be somewhere around here. Okay, and now we want to move, we want this piece to move with this reference plane. Because of course when we change the width of the door, we want this to move accordingly. So for this we drag the outer line of the extrusion back onto the reference plane, and then this little locket appears that we can close. And now when the width changes, this length changes of course as well. So we need to create another dimension to create this effect. And now when we create this dimension, make sure to select this side first, because this is the side that you want to move, and this side is the one that you want to stay in place. And now we need to create a parameter for that, and we're just going to simply name it A, because it's not a parameter that we're going to actively change, so it doesn't need to have a descriptive name. And now we want to put in a formula to calculate A, and we can do that in the family types simply by putting in a formula here. So how can we calculate A? A is the width of the door minus 2 times this side offset. So this is what we're going to put in here. And we can simply do that by writing the names of the parameter. Oops, minus 2 times side offset. Okay. And now let's finish off the extrusion to see if it works. So if we change the width now, oops, to 150, everything changes accordingly. So now we have 2 panels, but of course we don't want them to show at the same time. So what we're going to do is we assign a visibility parameter to them. So first for this one, we can see here in the properties that here you have this visibility parameter. So we click on this little gray box and then create a new parameter for this. So let's call this 0 because it's 0 degrees open at this point. And make this an instance parameter. Okay. Same goes for the other blade. And we create a new visibility parameter called 90 instance parameter and click OK. In the family types, we now find those two parameters down here, and we see that they have a box that you can tick. So either the 0 degree panel is visible, or the 90 degrees panel is visible, or you can also show both at the same time, but this of course does not make a lot of sense. Now maybe this becomes more clear when we import this door into a project so that we can try out all the parameters in an actual project. But first, of course, let's save it. So for this purpose, I drew this basic house, but of course also this house needs a door. So let's import our door into this project simply by clicking Load into Project. And then we can place it on a wall. And let's check it out in the 3D view. Here we go. This is our door that we just drew. And now we can check out all the parameters that we created. Now we can see that it is 90 degrees open at the moment. So here are our visibility parameters. So if we change that to 0, it's closed. And because those were the only parameters that we created as instance, we find all the other parameters under Edit Type, here in the Type Properties. So here we have the door material that we can now select something for. Let's make it wood. And the frame material as well. And then here you have all this thickness, height, width parameters that we created. And that still work here in the project now. So what we could do now, of course, would be to create another panel that is 180 degrees open so that you can fully open the door. So feel free to do that. It works the same way as we did with the 90 degrees. What is actually a lot harder is to create one that is, for example, 45 degrees openable. Also, of course, I'm aware that it would be nicer to have a door that you could seamlessly open to any position, and that's what I tried first by creating another reference plane that goes like this, just to show you, and then have a angular dimension between those, and then you could put the door panel on here and then just change the degree of that dimension to anywhere you want it. But it's actually quite hard to fix that point to a certain place so that it doesn't move when you change this dimension. So if anybody knows a solution to that, please share it with me. Well, but nevertheless, I hope you enjoyed this tutorial and you end up with this cute little door that is fully parametric and that you can open to 90 or 180 degrees. So, I hope you enjoyed this very broad look into parametric modeling in Revit and feel motivated now to create your own parametric families. I will upload the file to gumroad.com where you can download it for free and have a look at it. I will put a link in the description box so you know where to find it. And then if you enjoyed this video, feel free to subscribe to my channel and give my videos a like so I know what kind of videos you want to watch more. And then see you again next Monday with another video. Bye bye!